Hi guys, today I wanted to talk about the reason that I gave up on Gerbo and switched to Mach3. The first reason I already showed in one of my previous videos about the calibration tricks for 3-axis CNC. That Mach3 will allow you to adjust the perpendicularity of the X and Y axis in the software itself instead of adjusting in the hardware. A few professional machinists watched my video and told me that I better adjust it with the hardware instead of the software. But as professional, I don't think that they have to deal with the problem that we have as hobbyists on those machines. For example, I don't think that the stepper motor driver will overheat and stop working in the middle like mine in the last video. So here on this machine I have two stepper motor to drive two sides of the y-axis. Last time when that stepper motor stopped working, the axis started to turn, but I stopped it in time, but it still changed the structure of the machine. So if I adjust it with the hardware, I wouldn't have to do all the calibration all over again, and that would take a lot of time. And I'm sure that I couldn't finish the piece that I was milling because I would have to take the piece out to do all the calibration and stuff. So for now, I still prefer the software solution. The second reason that I wouldn't go into a lot of details today, that Mach3 will give you a lot of freedom to customize the user interface and also program all the buttons using the macro with a lot of advanced functions that make the machine work the way you want. As you saw in my last video, when I milled this piece, I lost the position in the y-axis, and luckily on that piece I have a lot of holes were already milled, so I can use those holes as reference to refine the position on X and Y axis. But I don't think that I will get lucky next time, especially when I do a lot of 3D art reliefs, that the top surface will be milled completely, and I don't think that there will be a lot of holes on the 3D art relief. So my aim today is to be able to recover the X, Y and Z axis position without using any reference point on the stock. I will start by making a prop plate that I will install it around the corner of the wasteboard so I don't interfere too much with the working area of the machine. The top surface of that plate will be lower than the surface of the wasteboard, just in case when I need to mill something that bigger than the wasteboard, so I can still put the stock on top of the wasteboard. I will cut the prop plate using this piece of aluminum stock, 3 by 8 of an inch thick, about 9.5 millimeter. As you can see that right now I am still using the surface of the stock to prop the tool. Later on, once I install this plate, I will use the top surface of this plate to prop the tool instead of using the surface of the stock. And that's it, it's done. And my idea about using this plate is that I'm going to use these two edges here to probe the X and Y axis position, and also later on I can also use this hole here to probe the X and Y axis using the center firing script. And this surface here we'll be using for the Z-axis tool probe. Next step, I will mill a pocket at the corner of the wasteboard to install this plate on. For me, I will use 2 short screws to fix this plate on the wasteboard because I don't want the screw to touch the aluminum plate here that connects to the whole frame of the machine, and the frame of the machine is connected to the ground. So my purpose here is just to isolate this plate from the frame of the machine. It is very sturdy and it doesn't move, so it will be very good to use as a reference. Next step, I will go on the computer, customize my Mach3 screen set, and also install all the scripts that I needed to use this plate. On the computer, it's very simple. You just open your web browser and search for Mach3 screen set, and then you probably will find it on the first link, screen set Mach3, and then click on it. Now you can just scroll down, and then you will see screen designer, screen 4, my screen, and screen tweak. I just got to use screen 4, so I click on download and save. Open it and extract it. Now just go in here and double click on screen 4. Once screen 4 is open, you are ready to modify the screen set. But before doing that, you should back up the original screen set. So I just go to Mach3 folder. I have it in C drive, Mach3. In Mach3 folder, you will see different screen set. For me, I will modify the 1024, either one for Mach3 mill. So I just click on it and copy it. You can rename it or you can just leave it at copy like this. And the one you will modify is this one. You can also modify the background and all the buttons just show up in the screen set. You can do that in the bitmaps folder. New bitmaps. In here you can modify whatever you want. For example, the button, the background. You only need to open the corresponding picture, the one that you want to modify in a picture editing software, and change it to the picture that you want. For me, I'm not changing anything for now, so I just go back to screen 4. To back up the file, it didn't take that long. Just to be safe, in case you make mistake, you never know. So here, back into screen 4, just click on open and choose the 1024 set. I will leave the resolution of the screen as default. Now the screen set is loaded. You can see that the Mach3 almost like running here, but it actually only for show. Now you can start editing the screen set. For me, I will focus on this area, tool information. There's a lot of things that I don't need here, like tool number, diameter, height, everything here I never really use. And with my machine, everything will be manual, so I can remove a lot of them. I just click on it and click delete. These two buttons, remember and return, I never know what they do, so I also just click on them and remove them. Now I can move this button around. I move it up here. I wrote 6 scripts for my use, so I will need 6 buttons. I can click on here and add another buttons, or I can just copy this button, so I just click on it and do Ctrl C and Ctrl V. 6 buttons. Just move them down here for now. I can arrange them later. This button, I can move it down here, and also this elapsed time. Now I can rename all the button here by double click on them. And button label text, I just rename it. I will need one button to zero the 2 on the Z axis, so I just name it Z 2 0 with plate. As you can see that the name is a bit too long for the button, so I have to make this button wider. So I just click on it, go to the edge until the mouse changes the shape to directional arrows. This seems to be fine. So now I can click on it and I can actually see the width of the button in pixel size. So I can put the same number for all the other buttons so they will look consistent. And also the top corner X is 432, so I will remember this and put the same for all the other buttons so they will be aligned. For the name of the second button, I will name it Z20 no plate. The Z20 with plate button is to use with the stock that are not conductive, for example wood or plastic. This one is to use with the stock that is conductive like aluminum. Next button I will rename it as get X, Y and Z offsets. Once you zero all the X, Y and Z axis, you will use this button to measure all the offsets on all the axes. This button here will be used to set the X and Y axis offsets in case you lost the position on the X and Y axis. This button move to Z probe point. The script that I will install on it will move the spindle to the same point every time you want to do the Z axis offset probe. And the last one will be set Z offset. For the buttons, I think I'm done, but I want to add a LED here that will show the status of the probe. Every time the probe is closed circuit, it will light up, and when it's open it will turn off. So just click on LED, click outside of the screen so the LED will show up. I will drag it in here, and I can make this LED bigger so I can see better. Like this, I think it will be fine. And here I don't have fourth axis, so I can delete those elements. These two rectangles here actually belong to the background of the screen, so I will have to modify the bitmaps. So I just go back to the bitmaps folder, background main. Well, I should copy this and modify the original one. I just open it with paint. I just select and copy this rectangle. Well, not perfect but good enough, so I'm just going to save it and close paint. Go back to screen 4. It haven't updated yet, but it will be updated next time when I reopen the screen set or open the screen set in Mach3. One thing I forgot about this LED is that I haven't set it up yet, because right now it doesn't have any code or anything. So this LED will act exactly as the digitized LED in the diagnostic screen. So I just click on diagnostics here and double click on the LED digitize. And the way I see it set up, that the OEM code function is chosen. and the code will be 825. So I will have to remember this. So I click OK. Go back to program run. Double click on this LED. Choose this one and put in 825 and click OK. So now this LED should work exactly the same as the digital LED. And as you can see that I can switch to the other subscreen like offsets. And you can modify also all the button and the layout in here the way you want it. For me right now I just keep it the same. So I just go back here, program run. Well, I think that's it. So I just going to save the screen set and close screen 4. Open the Mach3 Mill profile. Now Mach3 is open. As you can see, all the buttons here are updated. And also up here the force axis is removed. I have the LED here. So everything seems to be correct. Now I will show you how I'm going to install all the macros for each button. I just click on operator. Choose edit button script. As you can see that few buttons are flashing, so you can modify the script for them. For me, I will start with this one. I will open the script that I prepared. In here I have 6 scripts. I just open the corresponding name with the buttons. These 2 scripts I just found them on internet and copy them here. They work very well, so I just use them and don't need to rewrite anything. Just paste the script here, close, and save the change, yes. And that's it, this button is programmed. I will do the same for the other one. These 4 scripts I wrote them myself, so I put a lot of comments in the script as you can see here. If you go through the script and read the comments, I'm sure that you can understand what I am doing, and also you can modify and make the script work the way you want it. It didn't take me too long, so I'm sure you can do it. And that's it, all the script I installed. So now let's see how they work on the machine. Now I have the Mach3 screen set up and also all the script installed. Let me just show you the workflow that I will use with this probe plate. First of all, you should have a metal rod like this that we only use for probing. It should be really straight and round. In my case, I just use the shank of a broken bit that I have. It is 4mm diameter. So I'm just going to attach it to the spindle. Next step, I will choose a point to 0 or the X, Y, and Z axis. Because this piece of MDF is not conductive, I will use one side of this piece of angled aluminum at the probe plate. The thickness is 1.6mm. I just place it under the tip of the probe, clamp one of the probing alligator clips on the probe, and the other one on this piece. And then I just press it very firmly and click on the button Z20 with plate. So now the distance between the tip of the probe and the surface of the stock is 5mm. I will move it to a point here to 0 X and Y axis. Normally I will proceed to the next step is to get all the X, Y and Z axis offset using this plate. But in this video, just to show you that everything will work correctly, I will change the tool to a very pointy bit and go down until it poke into this stock and make a hole, so I can use that hole as reference to show you next time when I move to 0 that the tip of the bit should be inside that hole. Now I have a hole here at the X and Y 0 point, and the tip of the bit should be right in the middle of that hole. I will put the probe back. Because I took the probe out, so the z-axis 0 changed. So now I'm just going to reprobe the z-axis 0. Make sure that you will have to lower the tip of the probe close enough to the plate so it will be within the maximum moving range of the z-axis 2 probe process. Now I will try to move this away. Now I will click on go to 0. You will see that the tip of the probe should go exactly to the place of that hole and right on top of the surface of the stock. Right here as expected. So now I will go to the next step is to get all the offset values. Now the probe plate, make sure that it will lower the spindle so the tip of the probe will be lower than the surface of the probe plate. About 3 or 4 millimeters under the surface will be safe. Just remember to connect the alligator clip before probing. And here on the computer, just click on XYZ position offset. As you can see that for each axis, the probe moved 2 rounds to make sure that every time when it's measured, it will be consistent, and also the second probing movement will be slower than the first ones. That will improve the precision of the probing. Now I will change the tool to any other one, and then set the z-axis to offset using this surface. Afterward, when I click move to 0, the tip of that tool should be right in the middle of the hole that I drew earlier, and also the tip of the tool should be right at the surface of the stock. I'm just going to use the pointy bit again. Now I will click on the button Set Z to Offset. And go to 0. I don't know if you can see it with the camera, so let me just zoom in a little bit closer. Well, I think that the script worked perfectly. Now if you are in the middle of a cutting job that you will need to use another tool, so let me just change the tool to another one and probe the z-axis to offset again, and hopefully it will work exactly the same way. To test, I'm just going to use this long tapered bit. And this time, because I didn't lose the X and Y axis position, I will use the button move to Z to probe point. This way, when I probe the tool, it will be exactly at the same point that I used for the other bit. And click on Set Z to Offset. Now I will click on Go to 0. I think that the position of the bit is as good as it can be. Until now, I only show you how to use the z-axis to offset to recover the z-axis 0 point. but I haven't shown you anything about the X and Y axis offset. Those two offsets you only use in extreme case, like your stepper motor lose the step, or your machine lost power but your computer didn't, and the G-code still moving, and position on Mach3 is different compared to the real position of the spindle. Or like something happened to me last time, that one of the stepper motor stopped working, so the spindle position also wouldn't at the position that show on Mach3. In those cases, if we need to use the X and Y axis offset to recover the X and Y axis position, let me just show you a few examples what you should do in those situations. For the first example, I will unplug the power of the machine and then try to jog in Mach3. As you can see that the position on Mach3 changed, but the machine didn't move. So now I lost the 0 on X and Y axis. If I tell it to go to 0, it will move to some other point. I will turn on the power of the machine and show you that. Okay, so go to 0. As you can see that it moved to a point that is outside of the stock. Next step, I will show you the workflow how to recover the X and Y axis 0. I will install the probe back on and move it to the corner of the probe plate. You will repeat the process that you did earlier, except that this time you will use the button Set X and Y Position Offset. What this script did is that it probed these two edges and reset the X and Y axis offset value. So now if I tell it to go to 0, the tip of the probe should be right on top of that hole, but I haven't reset the Z-axis offset. So now I will change the tool back to the other tool and probe the tip of that tool to this plate, and then I will tell it to move to 0. And one thing that I also include in this script is that the spindle move to exactly the same point that you used to probe all the tools. I only need to move it straight down, close enough to the surface so it will probe faster. So now I'm just going to tell it to go to 0. As you can see now, the tip of the tool is exactly at the original point of X, Y, and Z axis zeros. With this setup, you don't need to worry about losing your reference on all the axes anymore. You can always recover their position precisely and consistently every time using the same probe plate that you can make yourself. In this video, I wasn't trying to convince you to switch to Mach3. I only wanted to show you what convinced me to use it. And you can see that it is really easy to customize the interface of Mach3 and also program all the buttons the way you want it. All the scripts that I use in this video, you can download them using the link in the description of the video. And I might actually convince you to switch if I tell you that I only spend few hours to read and understand other people's script, to learn a bit about the macro language of Mach3 and rewrite them to make them work the way I wanted as I show you in the video.